the impossible star chart. In 1900, divers recovered an ancient device from a shipwreck off the Greek coast. For decades, it was dismissed as a simple astronomical tool. Then researchers deciphered inscriptions covering the mechanism, revealing detailed astronomical data that shouldn't have been possible. The ancient Greek text described planetary cycles, eclipse predictions, and stellar positions calculated with precision that supposedly wouldn't exist for another 1,500 years. The inscriptions proved ancient astronomers possessed mathematical and observational capabilities that modern theories claimed were impossible. When the corroded bronze mechanism was first examined, scholars noted Greek text inscribed across its surfaces. The writing was fragmentary, damaged by centuries underwater. But as imaging technology improved, researchers could finally read what ancient craftsmen had inscribed. The text wasn't poetic or mythological, it was technical documentation. Instructions for operating the device, descriptions of what each dial displayed. Most remarkably, astronomical data encoded in the inscriptions showing calculations of planetary positions, lunar cycles, and eclipse predictions spanning years. Modern theory held that ancient Greeks had limited astronomical knowledge. They observed the sky and created models, but lacked the mathematical sophistication for precise predictions. The inscription text demolished this theory. The device's creators had calculated the Metonic cycle, a 19-year pattern of lunar phases. They'd determined the Saros cycle for eclipse prediction. They'd even accounted for the moon's irregular elliptical orbit using an epicyclic system. What made this particularly shocking was that the epicyclic solution for lunar motion wouldn't be discovered again until the 16th century. Yet, here was ancient Greek text from 200 BCE describing exactly this mathematical approach. Either ancient Greeks had sophisticated mathematical astronomy that was later lost, or our entire timeline of astronomical development was wrong. The inscriptions also revealed something academics found uncomfortable. The device wasn't unique. The text refers to it as following established design principles, suggesting there were other similar mechanisms. Ancient Greeks had apparently developed a tradition of complex astronomical calculators that left almost no trace in the historical record. When researchers first published translations of the technical inscriptions, many academics were skeptical. The calculations were too advanced, they claimed. The translations must be wrong, or the text was describing something simpler than it appeared. But as more text was deciphered, the evidence became undeniable. The inscriptions described gear ratios that precisely matched astronomical cycles. They explained how rotating the input crank would display planetary positions for any date. They documented knowledge of celestial mechanics that modern theories insisted ancient Greeks couldn't possibly possess. Perhaps most disturbing for established theories was what the text revealed about lost knowledge. If ancient Greeks could build mechanical computers calculating astronomical positions, what else could they do? How much ancient technology and knowledge has been completely lost, leaving us with a false impression of ancient capabilities? The academic resistance to accepting what the inscriptions clearly stated was telling. For years, scholars proposed alternative interpretations. Maybe the text described theoretical knowledge that wasn't actually implemented. Maybe it was copied from other sources without understanding. Any explanation was preferable to admitting that ancient Greeks possessed technological sophistication that contradicted modern theories about ancient limitations. The inscribed text on this single device collapsed multiple modern theories. It proved ancient astronomy was far more advanced than believed. It demonstrated that complex geared mechanisms existed in antiquity. It showed that ancient Greeks had mathematical knowledge supposedly developed much later, and it forced acknowledgement that our understanding of ancient capabilities has been systematically underestimated. The maritime trade records. In the 1970s, archaeologists excavating an ancient port city discovered thousands of clay tablets containing shipping records, cargo manifests, and trade documentation. When linguists translated the cuneiform text, they revealed a sophisticated international trade network spanning thousands of miles, 3,500 years ago. Modern theory held that Bronze Age societies were relatively isolated, with limited long-distance trade. The tablets proved this was completely wrong. ancient merchants were conducting complex international commerce on a scale that wouldn't be seen again for over 1,000 years. The tablets were found in what appeared to be a merchant's archive, systematic records of transactions, shipments, and correspondence. The text was in multiple languages, reflecting the international nature of the trade. Modern Bronze Age theories portrayed ancient societies as largely self-sufficient, engaging in limited regional trade. Long-distance commerce was thought to be rare, small-scale, and unsystematic. The tablet archive demolished this theory completely. The shipping records documented regular trade routes spanning from Egypt to Mesopotamia, from Cyprus to the Aegean, from Anatolia to the Levant. Ships carried copper, tin, silver, gold, luxury goods, and essential commodities. The trade wasn't occasional. It was systematic, frequent, and highly organized. One tablet listed a single shipment containing several tons of copper ingots, along with luxury items, textiles, and pottery. The scale was commercial, not the small-scale gift exchange modern theories proposed. Another tablet documented the merchant's accounts, showing dozens of transactions over a single year. This was professional international trade, not isolated exchanges. The text revealed sophisticated business practices. Merchants used letters of credit. They had agents in foreign ports. They formed partnerships spreading risk across multiple ventures. They employed standardized weights and measures for international transactions. The level of commercial sophistication was comparable to medieval Italian merchant houses, yet these tablets were from 1500 BCE. What made this particularly devastating to modern theories was the geographic scope. Tablets documented trade with locations thousands of miles apart: Egyptian gold, Cypriot copper, Mesopotamian textiles, Aegean pottery, all moving through systematic trade networks. The Bronze Age Mediterranean and Near East were economically integrated in ways modern academics had insisted was impossible. The tablets also revealed something that shattered linguistic theories. The merchants were multilingual, and texts showed they used several languages as commercial lingua francas. Bronze Age international trade required interpreters, translators, and people who could read and write multiple languages, a level of cosmopolitan sophistication that modern theories claimed didn't exist until much later periods. When the tablets were first published, many scholars rejected the implications. They argued these records were exceptional, that this one port was unique, that the trade documented couldn't have been typical. But as more archives were discovered at other sites, the pattern repeated. Bronze Age international trade was extensive, systematic, and sophisticated. The resistance to accepting what the tablets clearly documented revealed how invested academics were in theories of ancient isolation and limited capabilities. Accepting that Bronze Age merchants conducted complex international commerce meant rewriting Bronze Age history, reassessing political relationships, economic systems, and technological capabilities. The trade records forced acknowledgement that Bronze Age societies were far more interconnected and capable than modern theories allowed. They collapsed the narrative of ancient isolation and limited commerce, replacing it with evidence of a complex, integrated international economy that rivaled later historical periods. The advanced medical texts. In the 19th century, scholars translated ancient Egyptian medical papyri, expecting to find primitive medicine, magic spells, superstition, and ineffective treatments. Instead, the text revealed sophisticated medical knowledge, including accurate anatomical descriptions, effective surgical procedures, and treatments that modern testing has proven actually work. One papyrus described symptoms and treatments for conditions modern doctors recognize as accurate diagnoses. Another details surgical procedures performed with instruments and techniques that wouldn't be invented until the 19th century. The texts collapse modern theories that ancient medicine was primitive superstition. The most famous medical papyrus contained over 700 medical formulas and remedies. When chemists analyzed the ingredients and modern doctors evaluated the treatments, they were shocked to find that many were medically effective. Ancient Egyptian physicians weren't practicing superstition. They were practicing medicine that worked. Modern medical history portrayed ancient medicine as a mixture of magic, religion, and ineffective folk remedies. Hippocrates and Greek medicine were considered the beginning of rational medical practice. Egyptian medicine was dismissed as primitive, more concerned with appeasing gods than treating patients. The papyri proved this theory completely wrong. Egyptian physicians made accurate observations, recorded symptoms systematically, and developed treatments based on what actually worked. One text described symptoms of heart disease that modern cardiologists recognize as clinically accurate. Another documented treatments for infections that modern analysis shows contained antibiotic properties. The surgical texts were particularly remarkable. They described procedures for treating skull fractures, setting broken bones, and suturing wounds. The instructions were precise, practical, and medically sound. One text described examining a patient with a head injury by checking pupil responses, a neurological exam still used today. What shocked modern researchers was the anatomical knowledge demonstrated in the texts. Egyptian physicians understood the circulatory system, recognized the heart's role in circulation, and knew that pulse could be felt in various locations because it reflected heart function. This understanding supposedly wasn't achieved until William Harvey in the 17th century, yet these Egyptian texts were from 1500 BCE. The texts also revealed sophisticated understanding of disease transmission. One papyrus described quarantine procedures for infectious diseases, suggesting ancient Egyptians understood contagion. Another documented hand-washing and instrument sterilization for surgical procedures, antiseptic practices that wouldn't be discovered until the 19th century. When the papyri were first translated, many scholars tried to reinterpret the medical content. They argued that accurate-seeming descriptions were coincidental, that effective treatments worked for wrong reasons, that surgical descriptions were theoretical rather than practical. Any explanation was preferable to admitting ancient Egyptians possessed genuine medical knowledge. But as more texts were discovered and translated, and as modern medical analysis confirmed the effectiveness of ancient treatments, the resistance became untenable. The texts clearly documented sophisticated, effective medical practice based on observation and systematic knowledge. One particularly devastating revelation for modern theories came from texts describing medical specialization. Egyptian medicine had specialists, physicians who focused on eyes, teeth, internal medicine, or surgery. This level of professional specialization was thought to be a modern development, not something ancient societies achieved. The medical texts also documented medical education, descriptions of how knowledge was transmitted from master physicians to students, how difficult cases were discussed, how new treatments were evaluated. Ancient Egypt had medical schools producing trained physicians, another supposed modern development that the ancient texts proved existed millennia earlier. The papyri collapsed multiple modern theories about medicine. They proved ancient physicians weren't primitive superstitious healers, but knowledgeable practitioners using systematic observation and effective treatments. They showed that many modern medical concepts and practices existed in ancient Egypt, and they forced recognition that the history of medicine has been written with systematic bias, dismissing ancient knowledge because it contradicted theories about primitive ancient capabilities. The Navigation Manual. In 1960, researchers discovered an ancient Polynesian text carved into wood describing sophisticated navigation techniques. The text detailed a systematic method for crossing thousands of miles of open ocean using star positions, ocean swells, and celestial navigation, all without instruments. Modern navigation theory insisted such voyages required compasses, sextants, and charts. The Polynesian text proved ancient navigators crossed vast ocean distances using observation techniques so sophisticated that modern sailors struggle to replicate them. The discovery collapsed theories that ancient sea voyages were short coastal trips. Ancient mariners were making transoceanic voyages modern academics claimed were impossible. The carved wooden text documented a comprehensive navigation system passed down through generations. It described reading ocean swells to determine direction, using star paths to maintain course, and interpreting cloud formations to locate distant islands beyond visual range. Modern maritime theories portrayed ancient sea travel as primitive, coastal hugging, seasonal short voyages, and accidental discoveries driven by storms. The idea that ancient peoples intentionally crossed thousands of miles of open ocean was dismissed as impossible without modern instruments. The Polynesian text demolished this theory. It described deliberate, planned long-distance voyages using sophisticated techniques. Navigators learned to read multiple environmental signs simultaneously, building mental maps of ocean regions spanning hundreds of miles. The text explained how to use star positions not just for direction, but for latitude. Different stars rise and set at specific angles depending on latitude. By knowing which stars pass directly overhead at your destination, you can navigate toward it. This technique requires astronomical knowledge and precise observation. What particularly shocked modern researchers was the sophistication of the swell reading techniques. The text described interpreting multiple overlapping wave patterns, distinguishing between local wind waves and distant swells, and using deep ocean swells that reflect off distant landmasses to locate islands beyond the horizon. Modern oceanographers acknowledge these techniques were theoretically sound, but required observational skills and pattern recognition far exceeding what they had believed ancient peoples possessed. The text also documented systematic knowledge transmission. Young navigators trained for years, learning to recognize star patterns, memorize ocean swell directions, and interpret subtle environmental signs. This wasn't accidental knowledge stumbled upon. It was systematic scientific observation and education. When researchers initially published the text's contents, many academics rejected the implications. They argued that the techniques described couldn't actually work for true long-distance navigation, that the voyages must have been shorter than claimed, that luck played a larger role than skill. Accepting that ancient Polynesians intentionally crossed thousands of miles of open ocean contradicted fundamental assumptions about ancient maritime capabilities. Then, modern researchers attempted to replicate ancient voyages using only the techniques described in the texts. Sailing traditional canoes with no modern instruments, using only the navigation methods documented in ancient texts, they successfully crossed thousands of miles of open ocean, reaching specific island targets. The ancient techniques worked exactly as the text described. The navigation manual proved that Polynesian seafarers had explored and settled Pacific islands through deliberate, skillful navigation, not accidental drift voyages as modern theories claimed. The techniques they developed were sophisticated enough to allow intentional two-way voyages across vast distances, enabling colonization, trade, and cultural contact across the Pacific. The text also revealed how systematically ancient peoples had explored their world. The knowledge documented wasn't from a few exceptional voyages. It represented generations of accumulated observations, refined techniques, and systematic exploration. Ancient Polynesians had mapped the Pacific through deliberate scientific investigation. The discovery forced complete revision of theories about ancient maritime capabilities and Pacific settlement. Islands thousands of miles apart showed cultural connections that academics had dismissed as impossible. The navigation texts proved those connections were real, maintained by deliberate voyages using sophisticated techniques. The astronomical calculations. In 1881, a scholar deciphered ancient Babylonian clay tablets containing astronomical calculations. The cuneiform text documented mathematical predictions from planetary positions centuries in advance. Calculation modern astronomers verified as accurate. The tablets used sophisticated mathematical techniques, including concepts similar to calculus. Modern theory held that advanced mathematical astronomy began with Greeks and wasn't fully developed until the Renaissance. The Babylonian tablets proved ancient astronomers were using advanced mathematics over 2,000 years earlier than modern theories allowed. The tablets contained columns of numbers representing planetary positions at regular intervals. When modern astronomers analyzed the calculations, they realized the ancient mathematicians were computing how planetary velocities changed over time, essentially using techniques similar to differential calculus. Modern history of mathematics portrayed calculus as a European development of the 17th century. Ancient mathematics was thought to be limited to arithmetic and basic geometry. The Babylonian tablets proved this theory was completely wrong. The calculations showed Babylonian astronomers had developed systematic methods for predicting planetary motions with remarkable accuracy. They had observed patterns in planetary movements, developed mathematical models and used those models to make predictions centuries in advance. Modern verification of their predictions showed they were accurate to within fractions of a degree. What shocked modern mathematicians was the sophistication of the geometric methods the tablets documented. Babylonian astronomers had developed ways to calculate instantaneous velocity, how fast a planet was moving at a specific moment, using techniques that conceptually resembled modern calculus. They didn't use the same notation or theoretical framework, but the mathematical approach was fundamentally similar. The tablets also revealed that Babylonian astronomers understood concepts modern theories claimed weren't developed until much later. They recognized that planetary motion could be represented geometrically as areas under curves. They used mathematical series and interpolation techniques to improve prediction accuracy. Their work demonstrated abstract mathematical thinking at levels supposedly not achieved until Greek mathematics. Yet these tablets predated classical Greek astronomy by centuries. When the tablets were first published, many scholars rejected the interpretation. They argued that the mathematical sophistication was being read into the texts by modern researchers, that the Babylonians couldn't have understood the concepts their calculations implied. Some claimed the accurate predictions were coincidental, or based on simple pattern recognition rather than genuine mathematical understanding. But as more tablets were discovered and translated, the evidence became overwhelming. The calculations were systematic, sophisticated, and based on genuine mathematical models. Babylonian astronomers weren't just recording observations, they were developing mathematical theories and using them to make testable predictions. The tablets documented a continuous astronomical tradition spanning centuries. Observations were accumulated, patterns were recognized, mathematical techniques were refined, and knowledge was systematically transmitted. This was organized scientific astronomy using advanced mathematics, exactly what modern theories claimed was impossible for ancient civilizations. Perhaps most devastating to modern theories was evidence that Babylonian mathematical astronomy influenced later Greek work. Greek astronomers learned from Babylonian predecessors, adopting and adapting their techniques. The narrative of Greek invention of mathematical astronomy was revealed as Greek adoption and development of Babylonian knowledge that modern academics had systematically underestimated. The astronomical tablets collapsed modern theories about the history of mathematics and astronomy. They proved that advanced mathematical techniques existed far earlier than believed. They demonstrated that ancient peoples developed systematic scientific methods, and they forced recognition that the history of science has been told with European-centric bias that dismissed or ignored sophisticated ancient scientific traditions. The metallurgical instructions. In 1952, archaeologists discovered ancient cuneiform texts describing metallurgical processes in remarkable technical detail. The tablets documented techniques for alloying metals, controlling furnace temperatures, and producing specialized alloys, some of which modern metallurgists had difficulty replicating. One text described producing high-carbon steel using a process nearly identical to later Damascus steel techniques. Modern theory held that advanced metallurgy developed gradually through trial and error. The tablets proved ancient metallurgists understood the chemistry and physics of their processes at a theoretical level that shouldn't have been possible without modern scientific knowledge. The metallurgical texts weren't simple recipes. They were technical manuals explaining why specific processes worked. They described how different metal combinations produced different properties, how temperature affected metal structure, and how specific treatments altered material characteristics. Modern metallurgical history portrayed ancient metalworking as craft tradition, skilled practice based on accumulated experience without theoretical understanding. Ancient metallurgists supposedly didn't understand why their techniques worked. They just knew from experience that they did. The tablets destroyed this theory completely. Ancient metallurgists clearly understood causal relationships between processes and outcomes. They knew that heating iron with carbon-rich materials caused the carbon to penetrate the iron, changing its properties. They understood that quenching heated metal in water or oil produced different structural results. Their texts demonstrated genuine theoretical knowledge, not just practical skill. One particularly remarkable tablet described producing a specialized bronze alloy for specific applications. The text explained that varying the tin content changed the alloy's hardness and workability, and it specified exact proportions for different uses: weapons, tools, decorative items. Modern metallurgists recognize this as accurate materials, science requiring systematic experimentation and theoretical understanding. The steelmaking texts were even more shocking. They described a process of repeated heating, folding, and hammering that produced layered high-carbon steel with superior properties. This technique was thought to be a medieval development. The ancient texts documented it being used over 3,000 years ago. What made the tablets particularly problematic for modern theories was their systematic organization. The texts weren't random notes. They were organized manuals, apparently used for training. Ancient metallurgical knowledge was being systematically taught, implying schools or apprenticeship programs that transmitted technical knowledge across generations. The texts also revealed knowledge of related chemistry. One described purification processes for extracting metals from ores, including techniques for separating different metals from mixed ores. Another documented use of specific minerals as fluxes to aid metalworking, knowledge requiring understanding of chemical reactions. When researchers first published the metallurgical texts, many academics tried to reinterpret them. They argued the technical sophistication was being overread, that the processes described were simpler than they appeared, that the texts documented theoretical knowledge that wasn't actually practiced. But experimental archaeology proved otherwise. When modern metallurgists followed the ancient instructions, they produced the high-quality specialized alloys the texts described. The tablets documented metallurgical knowledge that modern theory insisted couldn't exist in ancient times. Understanding how carbon content affects iron properties requires knowledge of material structure at microscopic levels. Ancient metallurgists couldn't see microstructure, yet they clearly understood how to manipulate it, suggesting they developed sophisticated theoretical models through systematic observation and experimentation. The metallurgical texts collapsed multiple modern theories. They proved ancient metallurgists possessed genuine scientific understanding of materials and processes. They demonstrated that technical knowledge was being systematically taught and transmitted, and they forced recognition that modern theories have consistently underestimated ancient technological and scientific capabilities. The linguistic analysis. In the 1990s, linguists deciphered ancient tablets documenting a forgotten language. The texts revealed something extraordinary. The language contained grammatical structures and linguistic features that modern linguistic theory claimed evolved only in recent languages. The ancient tongue had developed sophisticated systems for expressing abstract concepts, temporal relationships, and conditional statements that supposedly required thousands of years of linguistic evolution to develop. The discovery collapsed fundamental theories about language evolution and demonstrated that ancient peoples possessed linguistic sophistication equal to any modern language. The tablets contained extensive texts in a language unrelated to known language families. As linguists worked to understand its grammar and structure, they realized the language possessed features that linguistic theory predicted should only appear in highly evolved modern languages. Modern linguistic theory portrayed language evolution as a gradual process. Ancient languages were thought to be simpler, with limited ability to express abstract concepts or complex relationships. Grammatical sophistication was believed to develop over millennia. The deciphered ancient language proved these theories wrong. The language had complex tense systems allowing precise expression of temporal relationships, not just past, present, and future, but subtle distinctions about sequence, duration, and completed versus ongoing actions. It had sophisticated mood and aspect markers. Its grammar allowed expression of hypothetical and counterfactual statements with precision matching any modern language. What particularly shocked linguists was the language's system for expressing abstract concepts. It had productive morphological processes for creating abstract nouns from concrete ones, extensive vocabulary for discussing mental states and philosophical concepts, and grammatical structures for expressing logical relationships. This level of abstraction supposedly required long linguistic evolution, yet this language demonstrated full sophistication thousands of years ago. The texts also revealed that speakers of this ancient language engaged in sophisticated philosophical and scientific discourse. The vocabulary included technical terms for mathematical concepts, astronomical observations, and philosophical categories. The language wasn't just grammatically sophisticated, it was being used for advanced intellectual purposes. When the linguistic analysis was published, many linguists rejected the conclusions. They argued that the complexity was being overinterpreted, that the abstract vocabulary was being mistranslated, that the grammatical sophistication didn't really match modern languages. The resistance reflected how deeply invested modern linguistics was in theories of gradual language evolution. But as more texts were deciphered and patterns became clearer, the evidence was undeniable. This ancient language possessed full linguistic sophistication, comparable to any modern language in expressive power, grammatical complexity, and abstract vocabulary. The discovery forced linguistic theorists to abandon models of language evolution that portrayed ancient languages as primitive precursors to modern sophistication. Language apparently doesn't evolve from simple to complex over time. Instead, all human languages, ancient and modern, possess similar underlying sophistication, just expressed through different surface structures. The texts also collapse theories about ancient cognitive capabilities. The linguistic sophistication demonstrated abstract thinking, logical reasoning, and philosophical reflection at levels supposedly not achieved until classical Greek philosophy. Yet these texts predated classical Greece by over 1,000 years. Perhaps most significant was what the language revealed about the culture that spoke it. The extensive technical and philosophical vocabulary showed a society engaged in sophisticated intellectual activity. The precision of the grammatical system suggested careful thought about meaning and communication. This ancient civilization wasn't primitive, it was intellectually vibrant and sophisticated. The engineering specifications. In 1837, archaeologists discovered ancient Egyptian papyri containing detailed architectural and engineering specifications. The texts describe mathematical calculations for structural loads, geometric methods for ensuring precise angles and measurements, and engineering solutions for moving massive stone blocks. Modern theory held that ancient construction relied on trial and error and simple techniques. The papyri proved that Egyptian engineers used sophisticated mathematics and systematic engineering principles. One text calculated the structural requirements for supporting a massive stone roof, using principles modern engineers recognize as correct applied structural mechanics. The papyri contained mathematical problems worked out in detail, calculating volumes of materials needed, determining angles for ramps, computing forces required for moving weights. These weren't theoretical exercises. They were practical engineering calculations for actual construction projects. Modern Egyptology had portrayed pyramid and temple construction as achievement through sheer labor and simple techniques. Complex theories proposed elaborate ramp systems or specialized tools, but generally assumed limited engineering knowledge. The papyri proved this assumption was completely wrong. The text demonstrated that Egyptian engineers understood principles of mechanics, geometry, and material properties. One papyrus calculated the slope ratio needed for a ramp to move blocks of specific weight using available pulling force. The mathematics were sophisticated, and the results were correct, showing understanding of mechanical advantage and force vectors. Another text described ensuring right angles in large-scale construction using geometric methods. The technique involved laying out triangles with sides in 3:4:5 ratio, using the Pythagorean theorem centuries before Pythagoras. The text wasn't just describing the practical technique, it explained the geometric principle, showing theoretical mathematical understanding. What shocked modern engineers was a text calculating structural requirements for massive stone roofing. The papyrus worked through determining beam sizes needed to support specific weights across given spans. Modern structural engineers analyzing the calculations confirmed they were correct applications of mechanical principles. Ancient Egyptian engineers understood structural mechanics well enough to design stable, massive structures. The papyri also documented systematic material testing. One text described testing stone blocks for flaws before use in construction. Another documented measuring and recording dimensions of quarried blocks to track inventory. This was organized engineering with quality control, documentation, and systematic procedures. When the texts were first published, many Egyptologists tried to minimize their significance. They argued the calculations were simple arithmetic, not genuine engineering mathematics. They claimed the techniques described were obvious practical methods, not evidence of theoretical knowledge. Any interpretation that avoided acknowledging Egyptian engineering sophistication was preferred. But engineers reviewing the texts had a different perspective. They recognized genuine engineering calculations, systematic design methods, and theoretical understanding of mechanical principles. The ancient Egyptians weren't just building through trial and error, they were doing engineering. The papyri documented engineering education. Problems were presented as teaching examples, with solutions worked out step by step. Ancient Egypt had engineering schools where mathematical and mechanical principles were systematically taught. This institutional approach to technical education was supposedly a modern development. The texts collapsed the narrative of ancient Egyptian construction as miraculous achievement without understanding. They proved Egyptian engineers possessed genuine theoretical knowledge, used systematic mathematical calculations, and applied engineering principles that modern engineers recognize as correct. The pyramids and temples weren't built by mysterious lost techniques. They were built by sophisticated engineers using knowledge that modern theories claimed they couldn't possess. The Agricultural Manual. In 2012, researchers fully translated an ancient Sumerian text that proved to be a comprehensive agricultural manual. The cuneiform tablet described crop rotation systems, soil management techniques, and irrigation engineering that modern agronomists recognized as scientifically sound. One section explained the nitrogen-fixing properties of legume crops, knowledge supposedly not discovered until modern soil science. Another described systematic selective breeding to improve crop yields. Modern theory portrayed ancient agriculture as simple farming with limited understanding. The Sumerian text proved ancient farmers possessed genuine agricultural science. The tablet was originally thought to be religious or administrative text. Full translation revealed it was a technical manual for agricultural management, written with systematic organization and scientific precision. Modern agricultural history portrayed ancient farming as traditional practice, techniques passed down unchanged through generations without understanding why they worked. Ancient farmers supposedly planted crops the way their ancestors had, following tradition without comprehension. The Sumerian manual demolished this theory. The text explained why specific practices worked, described the principles underlying techniques, and demonstrated systematic observational knowledge. Ancient Sumerian farmers understood agriculture scientifically. The crop rotation section was particularly remarkable. The text described planting sequences that modern agronomists recognize as optimizing soil nutrients. It explained that certain crops depleted soil while others restored it, specifically noting that legumes improve soil for subsequent grain crops. This knowledge of nitrogen fixation wasn't discovered by modern science until the 19th century, yet the Sumerian text clearly documented understanding of the principle 4,000 years earlier. The irrigation sections demonstrated sophisticated hydraulic engineering. The text described calculating water flow rates, determining optimal channel dimensions, and managing water distribution across large field systems. Modern irrigation engineers analyzing the techniques confirmed they were sound applications of hydraulic principles. What shocked modern researchers was the systematic approach to crop improvement the text documented. Sumerian farmers deliberately selected seeds from best-performing plants, maintained separate breeding lines for different characteristics, and evaluated results over multiple generations. This was systematic selective breeding, scientific agriculture practiced 4,000 years ago. The text also described soil management techniques that modern agronomy recognizes as effective, incorporating organic matter to improve soil structure, allowing fields to rest periodically, using specific plants to prevent erosion. Each technique was explained with reasoning, showing understanding of underlying principles. When agricultural historians first examined the translated text, many tried to reinterpret the content as simpler than it appeared. They argued that the crop rotation was coincidental pattern without real understanding, that the breeding programs were exaggerated, that the scientific-seeming explanations were being read into the text by modern researchers. But agronomists reviewing the text had a different response. They recognized genuine agricultural science, systematic observation, theoretical understanding, and practical application of scientific principles. The ancient Sumerians weren't just farming traditionally, they were practicing scientific agriculture. The manual documented agricultural education systems. It was written as teaching text, presumably used to train agricultural managers or administrators overseeing large-scale farming. Ancient Mesopotamia had institutional systems for transmitting technical agricultural knowledge. The text collapsed modern theories about ancient agriculture. It proved that ancient farmers possessed scientific understanding of soils, crops, and agricultural systems. It demonstrated that agricultural knowledge was being systematically developed through observation and experimentation. And it forced recognition that the development of agricultural science began thousands of years earlier than modern theories acknowledged. The mathematical proofs. In 2007, researchers examining an ancient Babylonian clay tablet discovered it contained mathematical proofs, formal logical demonstrations of geometric theorems. The tablet predated Greek mathematics by over 1,000 years. Modern mathematical history credited Greeks, particularly Euclid, with inventing mathematical proof, the systematic logical demonstration that theorems are necessarily true. The Babylonian tablet proved that formal mathematical proof existed a millennium earlier than modern theories claimed. The text demonstrated logical reasoning, systematic argumentation, and formal proof techniques that supposedly represented Greek innovation. The tablet contained geometric propositions followed by systematic logical arguments demonstrating their truth. When mathematicians analyzed the text, they recognized formal proof structure, assumptions stated, logical steps followed in sequence, conclusions demonstrated to follow necessarily from premises. Modern history of mathematics portrayed mathematical proof as Greek invention. Babylonian and Egyptian mathematics were thought to be computational, solving practical problems using arithmetic and geometry, but without theoretical rigor or formal proof. The tablet proved this theory was completely wrong. The geometric theorems proved on the tablet covered relationships between areas, angle properties, and proportion principles. The proofs used logical argumentation that modern mathematicians recognized as formally valid. This wasn't just calculation, it was theoretical mathematics with formal logical structure. What made the tablet particularly significant was its generality. The proofs weren't demonstrating specific numerical results. They were proving general theorems true for all cases. This abstraction and generality supposedly characterized Greek mathematical innovation. The Babylonian tablet showed this approach existed a millennium earlier. The logical structure of the proofs particularly impressed modern mathematicians. The text stated axioms, developed propositions, used previously proven results in subsequent proofs, and built a systematic logical structure. This formal approach was thought to be Greek invention, yet here it was in Babylonian mathematics centuries before Greek mathematics emerged. When the tablet was published, many mathematics historians resisted accepting the implications. They argued the logical structure was being overinterpreted, that the Babylonians weren't really doing formal proof, that the resemblance to Greek mathematics was superficial. The resistance reflected how invested modern mathematics history was in the narrative of Greek innovation. But mathematicians reviewing the tablet recognized formal mathematical proof when they saw it. The logical structure, the systematic argumentation, the formal demonstration of general theorems, these were unambiguously characteristics of formal mathematics. The Babylonians were doing precisely what Greek mathematics was credited with inventing. The tablet forced complete revision of mathematics history. Formal mathematical proof wasn't Greek invention. It was Greek development of older traditions. The systematic logical approach to mathematics existed in Mesopotamian mathematical traditions that Greeks learned from and built upon. The discovery collapsed the narrative of Greek mathematical exceptionalism. Greeks didn't invent mathematical proof. They inherited and developed it from earlier Mesopotamian traditions. The characterization of ancient mathematics as merely computational was revealed as systematic underestimation of ancient mathematical sophistication. The tablet also demonstrated that ancient mathematical knowledge was more theoretical and abstract than modern theories allowed. Babylonian mathematicians weren't just solving practical problems. They were developing general theoretical understanding and proving mathematical truths with formal logical rigor. These 10 ancient texts share a common impact. They collapsed modern theories. Each text forced scholars to admit they'd been wrong about fundamental aspects of ancient capabilities, knowledge, and sophistication. The pattern is clear. Modern theories consistently underestimated ancient peoples, portraying them as less capable, less knowledgeable, and less sophisticated than they actually were. When ancient texts proved otherwise, the academic response was often resistance rather than acceptance. What makes these discoveries particularly significant is what they reveal about bias in academic theories. The underestimation of ancient capabilities isn't based on evidence, it's based on assumption. Modern scholars assumed ancient peoples lacked knowledge and sophistication, then interpreted limited evidence to support those assumptions. When ancient texts directly contradicted the assumptions, providing clear evidence of sophisticated knowledge, the initial response was often denial. The texts must be mistranslated, overinterpreted, or exceptional cases. Any explanation was preferable to admitting the theories were wrong. But eventually, as evidence accumulated and the content of texts became undeniable, theories had to change. Ancient peoples possessed sophisticated astronomy, mathematics, medicine, engineering, and science. They developed theoretical understanding, systematic methods, and formal approaches to knowledge. They created educational institutions that transmitted technical and scientific knowledge across generations. These texts force recognition that human intellectual capability hasn't changed significantly over recorded history. Ancient peoples were as intelligent and capable as modern humans. What has changed is accumulated knowledge and available tools, not underlying human capability to observe, reason, theorize, and discover. The ancient texts that collapse modern theories are valuable not just for what they teach about ancient knowledge, but for what they reveal about modern biases. Academic theories about the past are shaped by assumptions about ancient capabilities, assumptions often based on lack of evidence rather than evidence itself. How many other modern theories about ancient history are wrong? What other ancient capabilities have been systematically underestimated? These texts prove that our understanding of the past is incomplete and often incorrect. The real question is, what will the next discovered text force us to completely rethink?